again, what actually is osmosis? So it's still passive transport, so it doesn't require any energy, we know that. But let's look at its definition. Osmosis is the net movement of water molecules from a region of high water concentration to a region of low water concentration. So it's effectively diffusion, but with water. So diffusion can just be, for any molecule, but osmosis is more specifically the term for the diffusion of water from a region of high concentration to low concentration. So again, looking at our beaker sample here to kind of explain to you how this works in a cell. So say here, these red molecules here are water molecules, and then these large green ones are glucose or sugar. And we have a selectively permeable membrane in the middle. So when diffusion begins, both the water and the glucose will diffuse across the membrane, but the water will be a lot faster than the glucose. And why is this? Because it's smaller. The water is significantly smaller than the glucose, so the water will diffuse a lot faster than the glucose will. And this mainly is just because it's a selectively permeable membrane, and the water, because it's smaller, moves through the selectively permeable membrane a lot faster than perhaps the glucose would. But they would both diffuse. And it would be the same if glucose, there's a higher concentration of glucose on the left, then going to the right, it would diffuse slower than the water going to the left. So that is basically what I wanted to demonstrate to you, that water diffusion tends to be really, really quite rapid because of its size, and they're very small molecules compared to the larger glucose molecules. So now, more importantly, osmosis happens all the time in cells for lots of different processes, which we'll look at throughout this course. So I just need to show you what we're going to look at now, which is the effect of osmosis on different cells. So let's go ahead and take a look at that now.